listen to the silence of space. Tonight, we will fall asleep to stories about the space station and those who work there. Just close your eyes and let the voices from NASA take you to the stars.
Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 19, Weather to Launch. I'm Gary Jordan, and I'll be your host today. So if you're new to the show, this is where we bring in NASA experts, scientists, engineers, astronauts, meteorologists, all to tell you everything about what's going on here at NASA. So today we're talking with Tim Garner. He's the meteorologist in charge for the National Oceanic and Atmospheric Administration, more commonly known as NOAA, here at the NASA Johnson Space Center in Houston, Texas. We talked about weather and how it affects human spaceflight, especially in terms of launches, landings, tests, and training, and even how weather could impact future spaceflights. So with no further delay, let's go light speed and jump right ahead to our talk with Mr. Tim Garner. Enjoy.
T-minus 5 seconds and counting. Mark. All launch commit lights are correct. There she goes.
Houston, we have a podcast.
Thanks for coming today, Tim. I guess I'll start off by just saying beautiful weather we're having, huh?
You bet it is. I will say that I'm in advertising, not production, so I didn't create it.
All right. Well, I'm excited about this topic today because you wouldn't immediately consider thinking about weather whenever you're talking about spaceflight, but it makes a lot of sense, right? Because everything we do eventually launches from Earth, right? It comes from Earth. So.
At some point, you go up through the atmosphere, and usually you come back down through the atmosphere as well.
Exactly. So that's kind of what I wanted to talk to you about today, just weather and how it affects human spaceflight. So I guess we'll just start off with just kind of how this is all structured. And I know we were talking a little bit just here in the beginning just about NOAA and NASA and those different layers, but so the part that you're in, the specific part, is called the Spaceflight Meteorology Group, right?
That's correct.
Okay, so what do they do?
Well, largely anything involved with the manned spaceflight program, the operations associated with that, launches are usually handled from 45th Weather Squadron, typically out at Kennedy Space Center. The Air Force handles the launch weather.
Okay.
So anything involving the landing weather and manned spaceflight, and it's controlled by the Mission Control Center here at JWST. Spaceflight Meteorology Group gets involved with that.
Okay.
So largely it's landing weather and some Earth observation stuff when you're on orbit as well, and a little bit of monitoring the local weather for JSC, which I think we'll talk about later.
Yeah, absolutely. And that's kind of like the broad spectrum of things, but it's part of, and when we're talking about the layers, Spaceflight Meteorology Group is part of NOAA, National Oceanic and Atmospheric Administration, right?
Specifically the National Weather Service.
Okay, yeah, that's right. There's even more layers to that. So what's just a general overview, even pulling back even more? What's NOAA? What's their concern?
NOAA is the agency that's charged with the oceans and the atmosphere. As a matter of fact, the man in charge, or the person in charge, is the Undersecretary for the Oceans and Atmospheres. That's what his official title is in the government.
Huh.
The National Weather Service is a part of that. It's charged with the promoting the nation's economy through the efficient issuance of weather forecasts and river forecast warnings as well. So That's what the larger role is. Okay.
All right. Nice little overview there. So then we're going back down to the Spaceflight Meteorology Group, thinking about spaceflight just in general. I mean, why is weather such a concern, or why is it a consideration when you're thinking about human spaceflight?
Well, most vehicles, they have some sensitivity to the atmosphere. And most people would think it'd be showers and thunderstorms, which are some of the bigger impacts.
Yeah.
But also the winds near the surface and the winds aloft. The winds aloft will affect the vehicle trajectory on launch and on landing as well. And as we get back to dealing more with reentry vehicles that use parachutes, they'll drift with the wind a little bit as well, and you want to make sure you hit your target.
Absolutely.
So knowledge of the upper winds is very, very vital to a successful landing.
Okay. So what sorts of things are you looking for then when you're looking at weather and making recommendations for spaceflight?
It'll depend in large part on the vehicle and its particular sensitivities to the weather, but almost all of them will have a sensitivity to lightning.
Okay.
Because you don't want to get any vehicle on launch or landing struck by lightning.
Definitely not.
You could build a vehicle that was perfectly hardened to just about any kind of weather, but it'd probably be too heavy to get off the ground.
Oh, yeah.
So it's like everything in space flight. It's a trade-off between weight and money and the ability to get into orbit.
Sure.
So a lot of the weather things impact that.
Mm-hmm.
Some of the newer vehicles as well, since they're going to splash down, or back to the future or back to the past in a certain way.
Yeah.
We're also worried about wave heights at sea.
Oh, yeah.
And the wind speeds at sea. And the vehicle can splash down in certain wave heights, but then you have a secondary problem of the people that go out there and take them out of the vehicle and recover the vehicle. They can't be exposed to high winds, high waves when they're at sea as well. And then when things come into land on the land with parachutes, for example, you don't want to come down too hard where the wind's being too high, because then the parachute will drag it over and it conceivably could drag the capsule along.
Yeah.
Usually that's a pretty high wind speed to do that, so those limits are usually set pretty high.
Okay.
To mention, we worry about showers and thunderstorms. You don't want, say, a parachute to get wet, or if you had a re-entry vehicle that was winged, you want to be able to see the runway as you're coming in. Mm-hmm. With a thunderstorm nearby, you have concerns with lightning. You could trigger lightning. Usually when an aircraft or a space vehicle encounters lightning, it artificially triggers the lightning. It's not usually naturally occurring. It's its mere presence in a high electric field will be that thing that sets off the lightning strike.
Wow.
And that's what happened for Apollo 12 on launch.
Huh.
Triggered lightning 2 times on launch.
Oh, wow.
And Atlas Centaur 67 in the late 80s triggered lightning upon launch. It was an unmanned vehicle.
Okay.
And that vehicle had to be destroyed because it got off the trajectory.
Oh, okay.
So we worry about lightning and thunderstorms quite a lot.
Yeah.
And if it's a winged vehicle or a parachute vehicle, if you're nearby enough to a thunderstorm, you could also encounter some turbulence, which would be a bad day.
Yeah.
So there's lots of things to worry about. You want to be able to see the vehicle. Clouds out there when you launch or recover the vehicle. A lot of times you want to have good videography of the vehicle. You want to film it so you can go back and do some engineering analysis later. So you want to be able to see it. Mm-hmm. Clouds get in the way.
Oh,
so
yeah.
we worry about that quite a bit as well. Some of the recent testing we've been doing in preparation for some of the missions upcoming, we're also dropping the test vehicle from high heights, either from an airplane or from a balloon. In the case for something that's being lifted up by a balloon, you want to know where the balloon's going to go before you drop something.
Yeah.
Because you don't want to drop it on somebody or somebody's house.
Of course.
And you want to keep it on the range. So you worry about the upper winds for things like that as well. So there's lots of different weather ideas that are out there that you got to look at.
Yeah. So you, in your position as meteorologist in charge, so when you're looking at this stuff, you say you're looking at this and you got to worry about that. You got looking at this, you got to worry about this. Mm-hmm. What are you doing to advise, to make recommendations? Are you there in the testing field, like saying, hey, you got to watch out for these winds, or how are you involved?
Mostly at the Spaceflight Meteorology Group. We're working in one of the multi-purpose support rooms in the Mission Control Center.
Okay.
There's a weather room, essentially. It's the single-purpose, multi-purpose support room, I guess.
Okay.
And we've got we've got 2 major weather systems back there. One that NASA's provided, that legacy system we've had for years and years, called the MIDS. And then I've got another computer system for weather stuff called AWIPS-2, which is in every National Weather Service office across the country.
Okay.
And both of those systems get weather satellite data, including the new GOES-16, which is a tremendous asset to the nation's economy and protection, and it's a wonderful satellite.
Yeah, I was going to say, that's the satellite, right.
And we also get radar data from the network of National Weather Service radars that are across the country. Also get data from the Air Force's radar at the Cape. They have a weather radar near Patrick Air Force Base as well. Receive that. Mm-hmm. And all the complete suite of weather observations from ground reporting stations, typically at airports, but more and more we're getting smaller scale measurements, mesoscale is what we call it. And a lot of those are special networks, including some that NASA operates, and the other space and missile ranges operate. They have dense networks of surface observations. And a lot of them are home hobbyists.
Oh.
We retrieve that data as well. It does need a little bit more quality control from time to time.
Sure.
But we do drag that in, so we actually have quite a lot of data. And then out in the field, they'll typically be, especially on the DoD space and missile ranges, where we do a lot of the activities. there'll be some meteorologists or meteorological technicians in the field, and they'll be releasing special weather balloons for us as well, and taking special surface weather measurements as well. And there's other technologies to measure the upper winds. There's some wind profilers that we use. So we collect all that data from the field back here in the MCC, and we'll advise the flight control team, primarily the flight director.
Okay.
My office is attached to the flight director office here at JSC.
Okay.
So I have a National Weather Service boss, and I have a NASA boss. My NASA boss is one of the flight directors.
Okay.
Typically the ascent entry flight directors.
Okay. Is that mainly when you're pulled in, ascent entry? Or
Yeah.
Okay.
When there's a mission or an orbit, we will monitor some things.
Sure.
For example, for the for the International Space Station, I'm on call if I'm not on console.
Okay.
So if they have some sort of emergency and they got to get into Soyuz and they want to maintain a situational awareness of where they could land, I can be called in and provide weather support for that as well.
Okay. And just make sure that, wherever they're going to land, you have a good idea of what
Yeah.
that weather's going to be at that time.
And for the Soyuz capsule in particular, it's pretty robust weather-wise. The
Yeah.
Russians make pretty hardy hardware.
Yeah. They've launched in cold weather and
Yes, they
winds
have.
and all kinds of stuff. So, yeah, excellent vehicle. You say you're back in mission control and you're getting all of these data from different sources. What are some of the key things that you're looking for? What do you need to make a informed decision? What kinds of data?
Typically be the wind speeds.
Wind speeds, okay.
Especially near the surface. And from the weather balloon, it'll be the winds that we measure aloft. We'll combine those observations with the computer model forecasts that we have, and we get those from our national center. And on occasion, we'll run some special localized models as well at a higher scale.
Yeah.
And we'll blend those together and come up with a forecast at the landing time.
Okay.
Also, we'll monitor the radar, of course. And a lot of people don't know this. There's lightning detection networks out there now, so we can tell where lightning's striking the ground.
Wow.
Yeah, it's pretty neat. There's several networks out there, and also we have what's called lightning mapping arrays, or which is a three-dimensional lightning display, which will show lightning bolts in 3 dimensions, so you can see the in-cloud flashes as well. I remember when I first got here and I saw that kind of data, it's like, wow, that stuff exists. And it's still, to this day, it's still really phenomenal and really neat to look at.
Absolutely.
Yeah. So that's how we monitor for the lightning data.
Okay.
With that in the radar as well.
So you can, obviously it has a lot of spaceflight applications, but that sounds like lightning data that could be used for something else, right?
Oh yeah, power companies use it all the time.
Oh yeah.
Matter of fact, I think some of the initial funds way back in the late 80s and early 80s got that started was some of the power companies wanted to know, when their lines were going to go down, that sort of thing.
Yeah.
So that's where a lot of the initial impetus for that kind of research and technology came about. But it's expanded into lots of sectors of the country right now.
Oh, sure. That seems, that's good data.
Oh, and there's a lightning sensor that's on the new JWST satellite as well.
Okay.
So, and it'll send data down to the ground every 20 seconds, and it uses an optical detector for that. So you have practically global coverage, well, at least half the globe that the satellite can see from geostationary orbit.
Okay.
So lightning data is everywhere now.
Yeah. What's more about the JWST satellite? What is that?
JWST is the new geostationary satellite, which means it sets in a same relative position over the Earth all the time.
Right.
It scans the Earth routinely every 5 minutes.
Wow.
It's got what's called 2 mesoscale sectors, which you can zoom in on a smaller part of the Earth, and it'll scan those every minute. And if you overlap those two, you can get data every 30 seconds. So it looks like a high-resolution movie. The visible channel is twice the precision of the previous era of satellites. So you see more data, smaller data, and it's also got more infrared channels, so you can see how the water vapor is moving around the atmosphere. You can see clouds. You can see areas that respond to sulfur content, so you can pick out volcanic eruptions, for example, with it.
Whoa.
Yeah, there's a lot of things you can do with it now. Get on the web, look for JWST, look for a high-res movie loop. It's really cool to look at.
Yeah.
And for a scientist, it's really exciting data.
Absolutely.
And for the spaceflight side of that, now that we get data more frequently, we can, if the situation's kind of dicey on what's going on with cloud cover, you can watch that right up almost to the last minute, and you don't have to wait. Previously we'd have to wait up to 15 minutes for the data to come in, and a lot can happen in 15 minutes.
Yeah.
For example, in the shuttle era, for the return to launch site abort, that was 25 minutes after landing. If we had to wait 15 minutes for a satellite picture, something can move a long way or form pretty quickly in that amount of time, which is almost the same amount of time you're trying to forecast.
Wow.
It's really nice.
Did the needs of the shuttle program sort of drive this, the need for quicker data?
No, not directly,
Okay.
but it's more or less just technology marching on.
Oh, yeah. Which it will do, right? So, the Ghost 16, I do remember seeing a lot of imagery when Harvey was passing through.
Yes.
There was a lot that was being monitored. I think soil saturation or something.
Soil moisture,
Soil
soil
moisture.
saturation.
Yeah.
One of the infrared channels will respond to water on the ground really well, and you can see the soils become saturated using the infrared channels. Some of
Yeah.
the near channels that respond to vegetation.
Okay.
Yeah, it's something we didn't have before.
Absolutely.
Yeah.
So, let's go to the shuttle program for a bit. Did you work the shuttle program, the weather for it?
Yes, I did.
Okay.
Since 1991 is when I arrived.
Okay.
And I've worked about 92 of the space shuttle missions.
All right.
And I was the ascent entry lead forecaster here at SMG for about 14 of those.
All right.
Yeah. So there's quite a lot of them.
Asset entry. Okay, so what did that look like? What sorts of things were you doing specifically for shuttle missions in Florida, launches and landings?
For Florida, on ascent day, SMG was primarily worried about the weather at the abort landing sites.
Okay.
One of those was the return to launch site, which would have been the shuttle landing facility there at the Kennedy Space Center.
Okay.
The interesting thing about that on launch day was while everybody was looking out towards the pad from the Launch Control Center, it looked out over the ocean. And if the sea breeze moved inland, you could have showers and thunderstorms occurring behind you over at the shuttle landing facility.
Oh.
So you'd look out one direction and it's great. Why are we waiting? And yet, 5 miles behind you, there was a thunderstorm going on.
Okay.
The other thing we would look at would be the transoceanic abort landing sites. Those were in Africa and Spain and later in France, and we'd monitor the weather for those as well. On launch day, you had to have good RTLS weather, the return to launch site, and you had to have at least one of the transoceanic abort landing sites had to have good weather. And we did actually scrub 4 launches for TAL weather during the entire history of the space shuttle program.
Wow. Just because nothing was lining up at those times.
All 3 or all 4 sites would be down for the weather criteria, and
Huh.
you were not a popular person on that day because that meant the weather was good at KSC and everybody's waiting for something that's on the other side of the ocean.
Right.
But keeping the astronaut safety in mind, that's why those rules were there.
Yeah. What were some of the big takeaways that you learned in your tenure at working the shuttle?
Mostly the newer technology that came along, and we got better and better at forecasting. Early on, we were kind of split between landing at KSC and at Edwards Air Force Base. Each site had its own unique weather issues. At Edwards Air Force Base, it's typically the surface winds were going to be a problem, either the crosswinds or a headwind for the shuttle.
Okay.
At KSC, we usually picked launch and landing times. We used some climatology to help pick those. So we usually would launch during the time of the day that was good for that. So the RTLS weather would generally be good. Once we had the ground up rendezvous to the space station, that meant you couldn't choose the launch time anymore like you used to. It used to always be early in the morning when the weather's typically good and the winds are light.
Okay.
But when you had a ground up rendezvous, you pretty much had to be in the same orbital plane as the ISS.
Right.
Which meant any time of day. Then we started moving into the late afternoon. We ran into more thunderstorms. We ran into more crosswinds because the way the runway's built out there, it's parallel to the coast. Sea breeze would come in with an east wind, that'd be all crosswind. So we got more and more instrumentation to track the sea breeze. We could do that with a really dense network of surface wind towers. You can also see it on the radar, and you can also see it on the satellite imagery as well. So the way technology's helped us with that, and then the advances in computer modeling for forecasting, it kept getting smaller and smaller in the scale that you could look at and the shorter times that you could look at, and it kept getting better and better. So things always seemed like we got much better as we got along in the space shuttle program.
Very cool.
Yeah.
So the shuttle program ended in 2011. Now we're in 2017. Looking forward to commercial crew launches here soon. What technology has been developing over these past couple of years that we can apply to commercial crew?
For commercial crew, we've got the newer satellite we've been talking about, GWST. We're getting newer and more portable weather balloon systems that we can use as well. I've got one back in the office where the ground receiver, it's a laptop computer and a handheld radio essentially, and a little tiny antenna. Used to you had to have a great big radio direction finder that would follow the balloon, or you would track it with radars.
Yeah.
Now it's all GPS based.
Okay.
So it's higher precision, more portable, more better everything, as a matter of fact. And as technology's gotten better, we've gotten better measurement systems and better forecasting systems as well. But in large part, it's still the same old meteorology we're using and applying for the new vehicles that are coming down, both SLS, Orion, and the commercial crew programs.
Okay. All right. A lot of the same stuff. So are you... Is the weather that takes place for launches and landings, what else besides, just mainly ascent and entry are you looking at that helps out with human spaceflight?
Oh, in terms of just about all the weather that you can think of, really.
Oh, okay. Yeah.
Like I said, it depends upon the vehicle. Sometimes you'll be looking at the humidity. Sometimes you'll be looking at the cloud coverage. Sometimes it's the radar. Usually it's all of the above.
Yeah.
And you also have to keep an eye out on things that aren't necessarily weather related as well. Because sometimes you'll see things on radar that look like a shower or a thunderstorm, and it turns out it's chaff. It's the same. It's what the military drops, tinfoil. They'll drop it, to fool radar. And when they're doing tests, that'll pick up on the weather radar.
I see.
And we've had that in the past during the shuttle program.
Okay.
That's one of the things. So you got to be aware when they're doing tests and exercises upwind from you, because that stuff will blow over you. So you got to keep an eye on lots of different things, what's going on there, as well as the state of the equipment. And on occasion, satellites, they'll shut them down when they're looking at the sun during certain periods. And if you're looking at low Earth orbiting satellites, you got to make sure it comes over at the right time. So there's a lot of different things, not just pure meteorology, but the logistical side that you got to maintain awareness of as well.
Yeah.
As well as knowing what the flight control team's doing.
Yeah. Is there so it sounds like a lot of the weather that you're looking at is within the atmosphere. You have a lot of data coming there. Is there anything that kind of goes into space? Is there a space weather element to this?
There is. Generally, the true space weather, things like solar flares, geomagnetic storms like that. There's a group here at Johnson Space Center called the SRAG, the Space Radiation Analysis Group.
Cool.
Yeah, they generally handle most of that activity, and they work closely with another NOAA center. As a matter of fact, there's the Space Environment Group, which is in Boulder, which is a National Weather Service office, and they maintain all the forecasts for space weather for the country as it is. But generally in SMG, the Spaceflight Meteorology Group, we're looking at weather primarily in the lowest, like 100,000 feet, although on occasion we do go higher for vehicles that come in on like a high inclination trajectory. Yeah, they're coming in an orbit that goes like 57 degrees north and south. During certain times of the year, you do have to worry about things like noctilucent clouds, which are about 82 kilometers high in the atmosphere.
Oh.
Yeah, we had a design criteria for shuttle for that, because you didn't want to fly through that, because it's a cloud and you're going very, very fast at those altitudes.
Yeah.
But they're generally restricted to very high latitudes. So we usually didn't have a problem with that, and the mission was designed around that.
Okay.
On occasion we did do some things that were up in the mesosphere, the stratosphere, the higher atmosphere, but generally it's what most people consider weather is what we're looking at.
Okay. So how does weather relate to climate? You're talking about looking at weather through long periods of time. You have a lot of data, and the data seems to just be, the instruments used to gather data are just getting better and better. Is there a relationship there, weather and climate?
Yeah, the old saying is, climate is what you expect. You expect winter to be cold.
Yeah.
And weather is what you get day to day. You can think of it a lot in terms like that. As I mentioned earlier, for the space shuttle, a lot of the missions were planned with climate data in mind, in that we knew that early in the morning winds were light.
Right.
showers and thunderstorms wouldn't be around. So a lot of those were planned with that in mind. A lot of the design criteria for some of the new programs coming up are looking into that as well. As we've gone and looked at the ocean wave climatology, especially in the North Atlantic. And a lot of the missions are designed with that in mind because in the North Atlantic, for example, waves get pretty high, especially in the wintertime. 20, 30-foot waves, they're not all that uncommon.
Yeah.
And you really can't design a vehicle to last very long if it should happen to splash down in that, either through some sort of contingency or an abort.
Yeah.
So most of the vehicles are designed that if they do abort, they'll turn around and avoid those areas. So that's one way climate data, long-term historical data has been used to help plan those kind of activities.
Right.
And the other thing is, even back in the shuttle days, when we used to land on the Edwards Air Force Base lake beds, generally they're dry, but they're still a lake bed. And we went back and looked at a lot of the data for that because sometimes they would fill up with water. And those typically happen during El Nino years, which are usually associated with heavier than normal precipitation and rainfall in the desert Southwest in the wintertime. So if we knew there was an El Nino year coming up, we had a pretty good idea that we might lose the lake beds and we'd have to land strictly on the concrete runway out there. So there's a lot of things you can use climate data for, generally in the planning and design stage for just about any spacecraft.
Is there major climate considerations for, or not necessarily major, but just anything you're watching out for commercial crew launches in the future?
There will be, at least in the sort of the shorter time span between weather and climate. Okay. Because for a commercial crew and also for Orion, when we go to the moon, some of those missions are going to be very long duration. So you're getting out past the typical ability to forecast day-to-day weather. So you're looking more at what the weather 3 and 4 weeks out might be like. And a lot of that is climate-based, and you can use some of the longer-range climate kind of weather patterns like El Nino or Madden Julian oscillations, things like that happen in the tropics to help you predict what the general trend that week might be. It might be drier that week. Might be less windy that week. Okay. Or it might be more stormy, which would drive more higher ocean waves, that sort of thing. We do look at some of that kind of data as well, even in the operations.
So when you say, beyond your capacity to look for weather, because, you're talking about Orion missions and, some of these moon missions are several days, several weeks, so you got to plan ahead, but you only can go toward a certain limit. I know, whenever I listen to the weather forecast or go and check it, it can only go for about 2 weeks, and even then it's, you throw your hands up in the air because you're not sure.
Yeah, the theoretical limit for about a day-to-day kind of forecast is about 2 weeks, and we're not even really that good yet. Okay. We've got computer models that'll spit those out all the time. Yeah. But there's larger scale, if you look more like towards the means and extremes, you can press that out and get a pretty good idea what's going to happen. Like I mentioned, 3 weeks from now, we expect it to be very dry that week. Yeah. That doesn't tell you it's going to be 34 degrees at 7 a.m. in the morning, but if you're just interested in, I don't want it to be wet, I've got this thing sitting outdoors that can't, get wet. I got payload sitting outside that can't get wet. Oh, yeah. That's a kind of good thing to know as well.
Okay, cool. So besides launches and landings and, planning for forecasts, what are the implications here at the center? Because we have mission control, and mission control has to make sure that we're operating. So I'm guessing there's certain implications for weather here at the Johnson.
Yes, there. I do maintain a basic sort of weather watch whenever I'm on duty for the Space Center. Okay. And for those on site, if you receive those email warnings from gens, some people usually pass those on. For the lightning alerts or notice of severe weather, I'll be the one generally sending those out. Okay. Matter of fact, I think it has my name on the bottom of it. And that's generally done for everyone's personal safety here on the center. Okay. For the mission control team, and a large part of that is to maintain so that they know if they're going to have any power outages coming their way. And also for some of the immediate planning for some of their communications to and from the spacecraft, especially the ISS, I'll monitor the local weather and also the weather at some of the TDRS downlink sites. Oh, that's right. White Sands Missile Range, and also over at Guam, they have another antenna. Okay. So monitor that, but for a tropical season, for like hurricanes, ISS flight control team, if they need to, they can shut down the center. They can relocate and set up shop someplace else remotely and still control the space station.
Right.
And part of that planning is, we want to know where the hurricane's going to go.
Yeah.
So I'll brief the flight control team here, as well as the center director and the emergency management folks here at JSC on the potential of the hurricane's track. And I'll tailor it so it's specific to the center itself and our operations.
Okay, I see. So what was Harvey like then? Because I know Harvey was pretty recent.
The Harvey was very recent. The interesting thing about Harvey is over the 4 days that it rained around here, we got, it was 40, I wrote it down, brought it with me because I couldn't remember it, 42.99 inches of rain here at JSC.
Whoa.
Which easily set a record. We had 20.72 inches of that occurred in one day.
Whoa.
So that's over a foot and a half of rain in one day. And, nearly 4 feet over the course of 4 days. So I sent out some messages and briefed the center directors and the emergency managers here at JSC during the storm. And also maintain these observations, which I don't know, your listeners, if they're interested, if you want to see what the weather is here at JSC, particularly on Building 30, there's some weather instrumentation that the Center Operations Directorate maintains. And I take that data and I post it out on the World Wide Web.
Okay.
So you can go to weather.gov/smg/BLDG30, Building 30.
Okay.
And it'll give you the latest weather from the rooftop. So I maintain that data going out for everyone to use.
Yeah.
Got another rain gauge here on site, an old style rain gauge out near Building 421. The interesting thing during Harvey was I came out on Saturday to empty that rain gauge because it holds 11 inches, and I figured it might fill up.
Yeah.
So I dumped it out, and it had about 7 or 8 inches. After that, I couldn't get back on site.
Oh, that's right.
Yeah. So that one, I don't know how much it had in it, but the rain gauge on top of the roof, it's what we call a tipping bucket. It continuously measures. So that's the one we know where we got 42.99 inches of rain.
Oh, okay.
Which is quite a lot of rain. But,
you
overall, the flooding here on site, directly on site, wasn't too bad, from what I understand.
Okay.
You just couldn't get here.
Yeah.
Or leave here.
Did you advise whether to shut down the center or did you have any contingency plans in place knowing the weather?
Leading up to it, briefed the center operations folks and the ISS control team.
Okay.
And also briefed the flight operations director folks that are in charge of the aircraft out at Ellington Field.
Oh, that's
whether
right.
or not they want to move some of the aircraft.
Yeah.
Most of them remained on site because it wasn't going to be a high wind event. It's mostly going to be a heavy rain event from Harvey around here. So most of those planes were left there. A few of them flew out.
Yeah.
So a lot of folks on site got briefings on that. Did that leading up to it. Over the weekend when it was raining, no one could get into work. Fortunately for me, I worked remotely. I had remote access to my weather systems here on site.
Oh, good. You had a connection.
I had a connection.
Yeah.
I could use almost everything I could that I could use when I'm sitting here.
Yeah.
Not everything, but pretty close to it.
That's good.
So I was able to continue the weather briefings and send out the JSC emergency notification system messages from home.
Right.
Yeah, so that's one unique way of working from home, I guess.
Yeah. No, it was completely necessary, right? Because everyone needed to stay safe during that whole thing. But you have instrumentation that's specific to Johnson Space Center, right? So when you're looking at this data, you can make decisions because you know that it's going to impact this exact area. Are there instruments that kind of do the same thing across the United States too?
Oh yeah.
Yeah.
The nice thing about JSC and especially Harris County, the county officials here around Houston, they maintain a really dense network of rain gauges and stream gauges, so they know how much rain is falling. It's the Harris County Flood Control District.
Okay.
They're really good at their job too, by the way. And, so you really got a pretty good idea where it's flooding and how hard the rain's coming down just about anywhere in the immediate area around here.
Wow. All right. Well, completely necessary for Houston, Texas.
Yes, it is. It floods a lot here. When it rains a lot. I learned that when I moved down here.
Yeah. Any big lessons that you learned or some just fascinating findings from this record-setting storm?
Just how much it rained.
Yeah.
The odd thing was we had forecast guidance that suggested it could be, that high, but no one quite believed it was going to be that much.
Right.
Of course, when you're telling somebody it's going to rain 20 inches in a couple of days, that's still really, really, really bad.
Yeah.
But to see 40 and, you know, upwards of a few reports of over 50 inches in the immediate area, that was just truly amazing.
Oh, that's right. Because
Yeah.
the 40 was just at Johnson Space Center.
Yeah.
That's not even considering other places.
And the sheer geographic extent of the 30-plus inch rainfall amounts, it was mind-boggling.
Yeah.
And I saw some reports from some GPS sensors that the weight of the water enough was measurable in the amount that it sunk the earth for a few days from the water rising,
Right.
residing on top of it. It was,
The elevation of Houston went down by like a centimeter or
Yeah.
something like that.
you know, that's just mind-boggling.
Yeah.
Use that word again.
Right. How many? What was the what? I forget the number of gallons. It was 50 trillion or something.
It's a huge amount.
Yeah,
You
was-
couldn't drink it, I know that.
Oh man, it was a lot though. What are we learning about hurricanes and how they affect mission operations? So what's the backup plan? If you know, I guess the plan right here was for the flight controllers and
They remained in place.
they remained in place, right? And they were doing everything. Nobody leaves. They set up cots and everything,
Yes,
right?
they did. Largely because we expected it to be a heavy rain event.
Yeah.
If it had been more of a stronger storm, if Harvey would have come ashore around Houston instead of down near Rockport and Corpus Christi, we probably would have shut the center down completely and they would have relocated. Because in that case, it had been a high wind event as well, because it came ashore as a Category 4 hurricane, as I believe.
Yeah.
And you would have had some storm surge problems as well. You know, you would have had water pushed up into Galveston Bay, and that would have gotten into Clear Creek, and water would have come on site. Now, the site does have some measures to protect some of the critical infrastructure from storm surge, but you'd be losing power, and you'd have to be on backup power, and then even in your backup power, if the water levels rose enough from the storm surge being pushed in, you know, you can lose some of your generators as well.
Oh yeah.
The interesting thing is, if you've ever visited the Mission Control Center, especially in the lobby, when you walk in, you'll see some gates that are lying flat on the ground. Those are designed for hurricane storm surge. Though, if we expect a large enough storm or a powerful enough storm to come ashore, they'll raise those little gates up, and that'll keep water from coming into the ground floor of the building.
Oh wow.
Yeah, you can see those as you walk into the lobby. They were put in 5 to 6, maybe 10 years ago. But
Okay.
yeah, so the building, it's got some protection from rising waters.
Right.
You know, most of them are designed for some decent wind speeds as well. I think the weakest part of the structure there is designed for 90 miles an hour, but the main part of the MCC can withstand much more than that, I think.
Wow. All right. Well, it sounds like they have a lot of protection just for the building itself, but then there's backup plans, right?
Yeah.
In case if they do, for whatever reason, evacuate the center, just get out, they can operate the International Space Station from remote locations.
Yes, they can. They've got a complete way of doing that from hotels,
Yeah.
as I understand.
Wow.
They can, move further inland here in Texas and do most of the controls remotely. They'll set that up, and they'll be in close contact with the Marshall Space Flight Center at the HOSC over there, and then in contact with the Russian control room as well. So they can, certain things that they may or may not be able to control, they could still pass off to either to the Russian control room or to the HOSC as well. But I think nearly everything they can control remotely. They'll take a whole bunch of laptops and send people out and run it from somewhere deep in South Texas or Central Texas.
Wow. Just hurricanes in general and how they affect the coast, and just these past hurricanes over just 2017, including Maria and all these that swept by. And I'm sure the NOAA, the GOES-16 satellite was checking out some data there, but is there some significant findings that we found from some of the hurricanes this year?
Well, there's a lot of them.
Yeah.
I think that'll wait until the season's over to analyze some of the data.
I see.
One of the interesting things they've done a lot this year, though, is it's a combination between NOAA and NASA. NASA's been flying some unmanned aerial vehicles around the hurricanes and above them, and they're dropping what's called a drop zone. It's essentially a weather balloon in reverse. It's on a parachute, and the unmanned aerial, it can drop like 60 to 100 of these little things around a storm and be up there in the air around it for 12 to 24 hours. So you can collect lots and lots of data on the immediate environment surrounding the hurricane, so you know what is steering it around.
Yeah.
So there's a lot of new technologies being flown by NASA and by NOAA out there, and I think some of that will help us get data into our computer models and make better forecasts in the future for hurricanes.
Right. And a lot of technologies to measure, a lot of scientific instruments, but has there been engineering challenges or maybe milestones to counter? Because you said you were talking about, you said it was Apollo 12 that got struck by lightning.
Yes.
But it kept going, right?
Yes.
So, I know they think they had to fix some things once they were up there.
Yes, they did.
Yeah. But what kinds of engineering things have been developed to protect from weather?
A lot of that's been procedural,
Oh, okay.
A lot of it's, you go to a lot of meetings here at NASA and you'll hear about the integrated vehicle, making sure the left hand knows what the right hand is doing. So, if you're protected for lightning here, but you're not protected for lightning over here, what happens if this part gets struck and it gets over through another means?
Oh, yeah.
So it's pulling together everything as a whole in terms of the natural environment, lightning or winds or whatever. A lot of that's been procedural now. There's a lot of things you can do now to harden things against lightning. But on the other hand, a lot of the technology is the exact opposite as well. A lot of airplanes used to be made out of metal skins. When lightning would strike the outside, it'd be conducted around the outside. More and more composite materials now. And they behave differently than metal. So a lot of engineering's got to go into looking at, when you use composites, how can you treat that for lightning strikes that might occur in the future?
Okay.
There's lots of little things that it trickles down to.
Yeah. A lot of the data, a lot of the instruments measure wind too, and wind seems to be just a giant consideration for space flight in general, which makes sense, right? You have things going up into space and coming down from space, and wind's going to blow it. But are there ways to sort of fight that? Is there, I guess, try to make it so if you're going to land, you have the best chance of landing where you want to, regardless of wind or something like that?
A lot of that's monitoring, either with weather balloons and we use radar wind profilers now.
Okay.
You can essentially take a phased array radar and point it straight up, and you can get wind measurements from that, even in clear air. There's one of those that's operated out at the Kennedy Space Center, really large ones. The antennas, a bunch of wires laying out in the field, and it measures winds up to 60,000 feet, and it gets them about every 5 to 6 minutes, which is really, really frequent.
Yeah.
So if you design things for your trajectory, the way things are still done today in large part is you measure the winds, and from past experience how much they'll change in 2 hours and 4 hours, and you protect against that statistically. But if you can push that further and further to launch time, because you can measure it more frequently, you can save a lot of launches, because you can say, oh, well, I'm protecting way too much here, or I'm not protecting enough, because I can see changes that are arriving late. With a weather balloon, you'd have to release it, and for one thing, it's blowing down range. It's not directly overhead.
Yeah.
So if the winds are high, an hour into the flight, the balloon could be 50, 60 miles away, and that's where you're really measuring the wind instead of like overhead.
Where you need to.
With a profiler, it's pretty much straight overhead.
Okay.
Aircraft can measure winds as well. Even the satellites, you can track cloud elements, and you can get an idea what the wind speeds are at certain heights as well. There's a lot of ways to do that. And even the usual radars that we use for weather, detect clouds and storms of motion.
Yeah.
They'll measure winds as well.
Wow.
So there's a lot of ways to do it now.
Is there other parts of the economy where all this data is being brought into? I'm sure the airline industry must use it, right?
Yeah. There's a large private weather industry out there. A lot of people don't know about it. Most people think there's only maybe three things in weather. There's the guy I see on television. Most frequently asked question I always get when I tell them I'm a meteorologist is, what channel do you work on?
Yeah.
And then the second one is, you work for the National Weather Service or the military, because they employ a lot. Or, you teach. But there's a large private weather industry out there that tailor weather information to specific industries. A lot of that does with energy trading. They'll advise them, if if you got a pretty good idea that 2 weeks from now it's going to be much colder than normal in the Northeast, you can go out and buy a lot of fuel oil, and you trade that just like anything. That's another piece of information to help you buy futures, for example.
Okay.
It's a big sector of the economy. The more I learn about that, the more I'm amazed at how large it is.
Yeah.
The insurance company, they want to know where hailstorms have occurred.
Oh, yeah.
Transportation industry, of course. Many years ago, I worked for a private weather firm.
Okay.
The trucking industry loved us.
Oh.
They could, if there was a big snowstorm in the Midwest, they could reroute all their trucks, drive further south, and they wouldn't get stuck for days on end.
Right.
So, and then of course, if you've ever flown on an airplane, you've had a weather delay.
Yeah. That's right. It's pretty expansive because weather affects.
Mm-hmm.
I guess you could say weather affects everyone.
Just about everybody.
Yeah. How about that? Awesome. So what's your background? How'd you get to go into meteorology, and how'd you end up in spaceflight?
Well, it's interesting that most of the people I've known that are meteorologists, there's only generally two kinds of us. Not completely true, but there's those that, well, I was in the military and had a math and physics background that made me one.
Oh.
And then there's that's all I ever wanted to do. Well, I'm one of that's all I ever wanted to do.
Oh, cool.
Ever since I was a child, that's the only thing I ever wanted to do.
Cool.
And fortunately, I was able to do that. And
Yeah.
I think that was largely, I grew up in Oklahoma, so you're worried about tornadoes.
Oh, yeah.
Although I tell you, the interesting thing about that, it was growing up in Oklahoma as a child, went to the University of Oklahoma, studied meteorology, never saw a tornado.
Really?
Never.
I was waiting for a good tornado story to say that's what inspired
Well,
me.
then, being scared by them, that was part of the deal that made me do that.
Oh, sure.
But my first job in the National Weather Service, I was stationed in Amarillo, Texas, and we got a radar indication of a tornado. So we issued a tornado warning for the county we were in. And somebody looked out the window and goes, "Hey, there it is." So that was the first one I saw.
It was in Amarillo, Texas.
Yeah, it was in Amarillo. The second one was a water spout down here at Galveston Bay, which we see from time to time.
Oh, okay.
Yeah. Matter of fact, just this summer, someone sent a picture to me on site of a water spout over Clear Lake.
What?
Yeah. I've got several pictures of water spouts from over Galveston Bay and Clear Lake that are nearby us over the past several years.
Oh, man.
It's since 2000, we've had 5, maybe 6 of them we've seen from JSC. So it's
5, maybe 6 in the past 17 years.
Yeah.
Okay.
So it's not entirely uncommon, but
Okay.
it's not common either.
Right.
But yeah, so we do have them here as well. So that's what got me interested into it with the University of Oklahoma. Studied meteorology. We're well known for severe storms. Then worked for a private weather company for a while. Then joined the National Weather Service and saw an opening for techniques development meteorologist at the Spaceflight Meteorology Group. Didn't know anything about it. Never heard of it.
Yeah.
So I applied. Somewhere along the line, they must have got the applications turned upside down, and they hired me. And I came in as a techniques development meteorologist, which meant I was developing forecast techniques and worked with the computer systems to make them friendlier for the lead forecasters who did the actual forecasting for the launches or for the abort landings and for the intermission landings for the space shuttle. And about a year and a half into that, I was promoted to be one of the lead forecasters. And since then, I've grown up to be the meteorologist in charge.
All right.
So I've gone from the ground floor to the penthouse, all at SMG.
Very cool. So how has your responsibility changed from, when you first came here and you said you were working 90-something?
92 missions.
92 shuttle missions to meteorologist in charge.
Well, given the current staffing, I'm the meteorologist in charge of myself. The size of the office has waxed and waned with the amount of flights we've got going.
I see.
So for right now, I'm doing everything. So
wow.
I manage the computer systems. I'm the property custodian. Never a good job to have. And so I do all the forecasting now for all the projects and tests that we're supporting. So I'm pretty much doing everything now. So I've learned a lot of management side of things.
Yeah.
And hopefully, sooner or later, the office will expand again because the amount of flights we'll have and programs we're supporting, that's really starting to ramp up now. We're doing more and more test support, qualification tests.
Yeah.
And the actual launches and landings aren't too far away now, so we'll need some extra people for that.
Oh, that's right.
It won't be as many as the shuttle. The new vehicles are less weather sensitive than the shuttle. That's one thing I've noticed so far. And that's a good thing.
Huh. Yeah, that's very true. So have you gone out to some of the tests to see how everything's working?
Yes, I have.
Okay.
I've been out to see one of the parachute qualification tests for the Orion capsule
Okay.
out at Yuma Proving Grounds. We were very, very close to the action.
Yeah.
Enough so that someone drove by and said, "Are you supposed to be here?" I said, "Yeah." The weather shack is really, really close because they're releasing weather balloons for the measure the upper winds.
Yeah, this is in Yuma, Utah, right?
Yeah, Yuma, Arizona.
Oh, Arizona. Okay,
Yep.
okay.
The funny thing I thought about that though was I had parked a rental car there, and I see capsule coming down under the parachutes, and it looks like it's really close.
Yeah.
And my first thought was, how am I going to explain to the rental car company a spaceship fell on their car? Fortunately, that didn't happen, though.
Yeah. Did you get the spaceship insurance, though, when you checked
No,
it
I
out?
did not get that. No.
Okay.
And I've been out on board some of the Navy ships that we used to recover the EFT-1 flight, that space capsule. Yeah, so I was the forecaster for that mission as well here at JSC.
Yeah, that
And-
was out. Did it land in the Pacific?
Landed out in the middle of the Pacific Ocean,
Yeah.
about 600, 700 miles southwest of Baja, California.
All right.
Out in the middle of nowhere. Not far from where the sharks like to hang out for some reason. It's one of the oceanographic things I learned about the mission. But yeah, I got to go out on board that ship and try to figure out where we wanted to place some special weather equipment on board.
Okay.
We ended up putting it right above the hangar on the back of the ship, so it worked out pretty well. The Navy's pretty handy with their stuff. They know what they're doing out there.
All right.
One unique thing about that is, for things that splash down, when you send people and equipment out, if something breaks, you can't go to the store to buy something. It's got to be with you, so you got to plan for every last contingency while you're out there.
Oh, wow.
Yeah.
So did you encounter like a failure that you had to kind of deal with, or you were prepared?
We were pretty well prepared. We had a meteorologist from Yuma go out and release the balloons from the ship for us.
Okay.
And one of the things he learned was, you can't take lithium batteries out on a ship.
Ah.
They don't like those on airplanes either anymore.
Yeah, right.
And he had a extension cord which didn't meet standards.
Oh.
Fortunately, they loaned him one, so we learned quite a bit from that.
Okay.
We'll be able to use for future Orion missions.
Yeah, take that all with you. Awesome. All right, well, I think that'll about wrap it up for today. I know I have a lot more questions about weather and climate and all that kind of stuff, but I guess we'll just save it for another time. But hey, Tim, thanks for coming on the show. This was really just eye-opening about just the world of weather and how it affects human spaceflight and just the operations here at the center too, but just all over the place. And it sounds like a pretty good job. I know you're doing everything, but at the same time, you're doing everything, so that's kind of cool.
It is a good job, and the more you learn about weather, the more you learn it impacts everything.
That's right. Okay, well, Tim, thanks so much for being on the show.
You bet.
Houston, go ahead.
Stop of the space shuttle.
Roger, 0G, and I feel
The
fine.
shuttle has cleared the tower.
indeed for all mankind.
It's actually a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Houston, welcome to space.
Hey, thanks for sticking around. So today we talked about weather and how it affects human spaceflight with Tim Garner, the meteorologist in charge here at the NASA Johnson Space Center. So if you want to know more about what's going on here at the center, nasa.gov/Johnson is a great resource for everything NASA Johnson Space Center. Obviously, we have social media accounts for the Johnson Space Center, Facebook, Twitter, and Instagram. If you want to know about the International Space Station or commercial crew programs and what's going on, we kind of alluded to some of the developments going on in the commercial crew program especially, and soon we're going to be launching America. So if you want to know what's going on there, just go to nasa.gov/commercial crew. nasa.gov/ISS is also a good resource, and of course, all of those are on Facebook, Twitter, and Instagram as well. If you have a question, just use the hashtag AskNASA on your favorite platform. If you have a question about the weather, we can answer it in a later podcast like we've done before. Or if you have a suggestion for a topic that you really want us to cover, just let us know using that hashtag, and just make sure to use HWAP, HWHAP in that post so I can find it, and then we can make an episode on it. So, and for everyone so far who has submitted submitted some ideas. Thanks so much, because we've actually been looking at them and have already made some episodes dedicated to some of your questions and answered them. So thanks again. This podcast was recorded on October 25th, 2017. Thanks to Alex Perryman, John Stoll, and Jenny Knotts for helping out with the episode. Thanks again to Mr. Tim Garner for coming on the show. We'll be back next week. Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, Episode 20, Special Delivery. I'm Gary Jordan, and I'll be your co-host today, along with Matt Buffington, Director of Public Affairs at NASA's Ames Research Center in California, and the host of NASA in Silicon Valley podcast. Matt, what's up?
Hey, Gary. We're doing great. So glad that we could team up on this. This is also concurrently Episode 69 for NASA, for the NASA in Silicon Valley podcast. There's a ton of overlap between our listeners, so I'm really glad that we were able to make this happen.
Yeah, me too. Today is a very special episode because we're teaming up with NASA in Silicon Valley podcast to talk about some of the things that we can find in a cargo vehicle when it's shipped to space, which is perfect because SpaceX will be sending its Dragon cargo vehicle to the International Space Station here soon. So who do we have from Ames, Matt?
Over here, we're bringing in Dennis Levison-Gower. He's a project scientist here over at Ames and has tons of experience working on cargo, working on payloads, and sending them on up to the space station. So how about over there in Houston?
So we'll have Shane Kimbrough. He's a NASA astronaut who recently spent about 6 months on the space station and landed earlier this year. And we've actually had him on the podcast to talk about his landing experience back in episode 3. But while he was up there, he had quite a few cargo vehicles visit the station. He had the SpaceX Dragon, Orbital ATK Cygnus, Japanese HTV, and the Russian Progress, all within his 6-month stay aboard the station. So it's fair to say he knows what cargo on station is all about. He performed hundreds of experiments with the science that was delivered on some of those vehicles and even got some fresh food, so I'm excited to ask him about that experience.
Awesome. So I'm really excited to get the different perspective on both the science, on the space station, so we can see the astronaut's point of view and the people who actually designed those experiments.
Yeah, this is going to be a good episode. So, with no further delay, let's go light speed and jump right ahead to our talk with Shane Kimbrough and Dennis Levison-Gower. Enjoy.
T-minus 5 seconds and counting. Mark. All launch commit lights are correct. There she goes.
Houston, we have a podcast.
Okay. All right. Hey, it looks like we're all connected, ready to go. How about this? Houston, we have a podcast and NASA in Silicon Valley combined.
Yeah, this is going to be sweet.
Sweet, I know, I'm pumped. And we're doing this remotely, so here in Houston, I'm in the studio with NASA astronaut and no stranger to Houston, we have a podcast, Shane Kimbrough. Shane, thanks for being here.
Hey, great to be here.
Cool, and how about over in Ames? Matt, who do you have?
Yeah, well, I'm sitting over here with my buddy, Dennis Levison-Gower. We actually go way back from SpaceX 8, was it, Dennis?
That's right.
Yeah, so I always remember it because it was the first time that SpaceX had launched a rocket and landed it on a barge. And Dennis was nice enough as I drove him back and forth from his office to do press interviews and stuff. So
nice enough indeed.
Exactly. So I always like to start our podcast with the question of how did you get to NASA? How did you end up in Silicon Valley? But I definitely want to hear about that from Shane as well. But let's start off with Dennis. So tell us about how did you end up at NASA?
Well, I really ended up here by accident.
Nice.
I was set to be a professor, discover things, have graduate students. I did a PhD in biochemistry. Then I went to Stanford for a postdoctoral fellow, doing bone marrow transplantation, graft versus host disease, immunology. And slowly over the years, I thought, I'm gonna go to industry. I'm not gonna do the academic track anymore. It was kind of a slow evolution. So I was out there, had my resume posted on job sites and stuff, looking around. Just got an email saying, do you want to, are you interested in a position at NASA Ames?
Really?
And I'm like, this is spam. I don't know anything about rockets. I'm not an engineer. I don't, I'm a biologist.
Yeah.
So talked to my wife. She's like, you have to apply. It's NASA.
Yeah, absolutely.
So I thought, well, all right, at least I could go and see the base and kind of look around because I saw it on the side of the highway. So I knew there's some NASA thing here. Mm-hmm. And it was when I talked to the hiring manager, she really convinced me that this was a really cool opportunity. Kind of got me into a different headspace of not just doing basic research, but doing applied research and working with a whole different, cadre of engineers and operations and safety.
Yeah.
And I don't know, it just really appealed to me. So I took a chance and took the job.
Yeah, that's pretty awesome. Like I always say, like when people think of NASA, they think of rockets and telescopes. Biology is a huge part of that. Speaking of biology, sometimes we have humans up in space. So
Excellent segue.
I know, right?
All right, well, Shane, let's. How about you? How did you become an astronaut?
Well, I came, there's several, obviously, avenues to get to be an astronaut. I came through the military. I was an Army officer, Apache pilot, my whole Army career. I took a little detour towards the end of, I would say, my conventional Army career when I went to graduate school at Georgia Tech, and then I went to teach math at West Point for a few years. And then from there, I was called to come work down at Johnson Space Center for a few years. So I'd applied to be an astronaut that year, didn't get selected, but the good news was I was, I guess, somewhat in the highly qualified category. So the Army detachment down here asked me to come down here and work for a few years. And that was to really get ready for the 2002 astronaut selection. Guess what? That selection never happened. So we went through the whole thing, interviews and everything, and it never happened. So Congress decided they didn't need a class that year. So we hung around for another couple of years, which in a way was, somewhat rolling the dice on my Army career. But my wife and I felt it was kind of where we wanted to be and what we wanted to do. So stuck around and was lucky enough to get selected in 2004.
Lucky and persistent enough.
So, yeah, persistence is a big trait, I think. It was my fourth time to apply. So.
All right.
I was going to say, isn't that normal for astronauts? Because we had Steve Smith like a while back on our podcast, and I think he had applied like 3 or 4 times as well.
Yeah, I think at least it used to be the norm. A lot of times these days, at least in the last couple of classes, we've had a lot of first-timers. But yeah, for folks a little older like myself, yeah, I think 3 or 4 times was pretty normal.
Yeah. Now I remember talking with the 2017 class, and a couple of them applied multiple times. I know for sure Roger Chari did, but yeah, you're right. A couple of them were first timers. But then you got folks like Clay Anderson who applied like what, 8 or 9 times or something.
Wow.
So yeah, right.
Persistence.
Exactly, persistence, and it works out too. All right, well, this is perfect to combine forces for the podcast today. Houston, we have a podcast, and NASA in Silicon Valley, because today's topic is cargo, and cargo going to the International Space Station. And Shane, I feel like you're the perfect person to have on the podcast today because you've seen your fair share of cargo vehicles on your last mission, right?
Yeah, we saw everything, and we saw Cygnus twice. So we had a lot of vehicles coming and going, and really cargo, when you think about it, it's the way we handle the logistics problem on the space station. It's a big logistics problem if you think about it, to get equipment and clothes and food and experiments to that orbiting laboratory. So how do we do that? We used to do it with the space shuttle. It was nice and easy. It could haul a bunch of stuff. Now we can't do that. So we have these cargo vehicles that you're talking about.
Yeah, that's right. Because on your way to the space station, you can bring stuff, but now, you need stuff delivered, right? I mean, it's a huge complex. It's the size of a 5-bedroom house. It needs stuff, right? Exactly. Food, supplies, all that kind of thing.
Well, that's one of the funny things as we were coming in, especially as we're getting closer for the SpaceX 13 launch coming into it, and we see like there's the both sides. There's like the people up at the space station working on receiving the cargo or even like science experiments, but then also on the flip side of how do you get that stuff prepared? That is a feat in of itself.
That's true. So Dennis, what do you have to do to prepare stuff to go on cargo missions?
Oh, that's a big question, because I mean, it really starts 1 to 2 years ahead of the launch.
Really?
If you think about it, or more, because after you have an experiment defined, you've got to prepare exactly what the science requirements are. Then you've got to start making a plan. Then you've got to start assessing what the hardware needs are and the kit's needs are. Then you have to design those. Then they have to get through safety. You have to plan operations. You have to plan how everything's going to be labeled. And then usually, I think somewhere between like 3 and 6 months before launch is when we're going to actually have to have things prepared, off-gassed, tested, HFIT, label committee, all those things. And do the early load, and then we start preparing the late load chemicals and perishables that really have to be loaded 25 hours before launch, and we do that out at Kennedy Space Center for SpaceX launch anyways. So there's kind of a whole experiment development cycle that happens, and that's just for like one payload. And if we have 5-6 payloads from Ames coming out, It's a lot of work from a lot of people to send like a box of something.
It takes a village for it to gathering all that stuff up. But I'm always curious, like on your guys' side, on Shane, for you guys, like when you receive this cargo, like how exactly does that happen, or how does that work? Do you guys just, I mean, you're like you're unpacking the trunk from a trip, you know?
Yeah, no, we're always excited to open up the hatch and get new stuff. It's kind of like Christmas every time we get one of these vehicles up there. But the way we go about unpacking is very organized, and it has to be that way. We have a great team on the ground that gets us ready and prepared with all kind of documents and keeps us organized with charts and things on how they want it to be unpacked. And so we follow that, religiously. We'll have somebody in the crew is going to be called the load master, and that person's responsible for that vehicle. If we just start pulling things out and stowing things where we want to stow them, that's not the way it's going to be, because we'll never find that stuff. So we really have to be disciplined and put things where they're supposed to go. A lot of times that means we'll take one bag out, and the bag will have 100 different items in it, and we have to go put those 100 things somewhere. So it's not as easy as pulling a bag out and stuffing it somewhere. Sometimes it is, but most of the times it's not. So we've really got to make sure that we're all helping each other out, and it's always better to, as I found with all these cargo ops, to do it as a team versus doing it individually. You're much more efficient, and you can have one person kind of reading the book, keeping control of everything, and the other couple people running things around, and that really worked well for us.
Wow. So everything has an order and a destination, right?
Absolutely.
You unload this first and put it in this location, and it's all scheduled that way.
Yep.
How long does it take you to unload completely?
I think we actually set some records for unloading vehicles the quickest, which is a good thing, I guess. But we really, we did it by working together as a team, and that's the only way. Tama and Peggy and I would knock out a vehicle, no kidding, in a day and a half or two. But that's pretty unusual. That was kind of, if it happened to show up, maybe just before a weekend, we kind of used the weekend to do it. So it was kind of a freebie. Where if they had it just planned out during a normal week, it would take a week to 2 weeks sometimes, depending on the vehicle.
That's right, because you got to fit it with everything else that you're doing.
Right, exactly.
Wow. Amazing.
And a lot of that, I'd imagine, it's already complicated enough. And I'm sure it's crazy complicated even just within NASA. But then you start throwing in all these private companies and different groups. Is everybody, how do you keep, I don't know, maybe you guys could talk about, how do you keep everybody all on the same page on how things get prepared? Because, Dennis, you're preparing the stuff for these companies, but then,
I think they all go through NASA. Yeah. You'll have private hardware developers, but the manifest is controlled through NASA, and the crew procedures are controlled through NASA. Shane, correct me if I'm wrong, but at some certain point, it has to be layered into the controlled process of NASA. Even if it's so you could think of it as NASA buying things from different vendors, but then they'll manage how it goes up, and or they'll manage it through SpaceX how it goes up.
Yeah, totally agree. We saw differences, of course, because the vehicles are all different inside. So the way they, location coding is all different, and where things might be on one is different than another. So that's the only difference. But bottom line is you're going to get a bag, you're going to take it somewhere, you're going to take it apart, and then take those things somewhere. And if we keep it pretty simple like that, it made it easier on the crew.
Definitely. You're the pro mover when it comes to cargo missions.
You're going to get a reputation here, man.
So what are some of the main differences then in terms of, so Dennis, on your end, for qualifications, and we can start with that, what's the difference to get it on that vehicle? But then Shane, for unpacking it, some of those little tiny things.
The biggest thing for us is always safety. We go to great lengths to try to have chemicals that will not interfere with the life support system, that won't be toxic to the crew if they're spilled. Everything that has a tox level will have certain levels of containers and containment that have to be layered onto how it's packaged and how it's stored. Then we have human factors. We have to make sure that the 5% Japanese female and the 5% American male can handle the things. And then even right before it's loaded, there's an expert that comes in with gloves on and feels everything, make sure there's no sharp edges on anything, and that is not going to hurt anybody when they start pulling them out of the packages. So that's what I've seen on my end, big picture.
Yeah, I'd say from our end, it's very similar, like I mentioned before, but there are some things that every vehicle that gets there's some critical items that need to come off first. And we're well aware of what those are based on the ground team prepping us for that. And most of the time, those are kind of delicate experiments or things like that have to come off or time sensitive. So we'll obviously hit those first, and then after that, we'll just follow kind of the script that the ground lays out for us so that we're all on the same sheet of music and everybody knows what's going on. Even if we're doing it in our spare time where the ground control team might not be following, we can kind of just update them with, hey, we did, sections 2, 3, and 4, or whatever it was, and then they'll be caught back up with us when they get back on console.
Yeah, like if you're doing it on a weekend or something.
Correct.
Sweet. Yeah. So what's an example of time critical? Since you unpack so many vehicles, what's an example of a time critical experiment you had to unpack?
We had some rodents on board, so that was one thing we had to get off. Those are always time critical, just to get them set up in their habitats on the space station. That's one. I think some that just showed up today, actually on the space station, were things like pizza and ice cream. So
definitely time critical.
If you get things like that, those are time critical because you need to eat those quickly. But anyway, there's plenty of different, wide range there I gave you, from rodents to ice cream. So,
and I have to chime in on that because this isn't just like the sad dehydrated stuff you buy at the museum. This is like a legit pizza.
This is the real deal. Apparently, it's the first time I've heard of a pizza delivery going to the space station. So whatever company got that's going to be
30 minutes or less.
Yeah, it's not going to be the best pizza, but it'll probably taste good to you guys.
Yeah. Ice cream's legit, though. Of course, we didn't have anyone out there, but shortly after I left, they got some, and they're getting some today. So
they waited till right after you left?
Apparently so.
Oh, man.
Well, after SpaceX 8 launched, all the guys on the ground at KSC had all these Klondike bars, like just filling the freezer. And I'm like, where do these come from? And they go, well, the CMC team, the cargo team, when they were packing all the cold stowage, if there's any empty areas in the freezers, they just start stuffing ice cream bars in there.
Oh, that's hilarious.
It's just a surprise for the crew. So then we had extra boxes of Klondike bars.
Cool. Always a welcome treat.
But when you're unpacking doing this, are you in constant contact with the ground and they're like walking you through it, or it's just a mix of sometimes you are, sometimes you guys just get your to-do list and you just kind of make it happen and update them later on?
Yeah, we have a couple meetings beforehand, of course, before the vehicle gets there, and there's a whole choreography that they want us to do and the order they want us to do it in. And so we really were disciplined and followed that to the T. A lot of times we'd have questions or something wouldn't be where it was supposed to be, and that's where we'd kind of just call down real quickly and touch base with whoever was on console for that, so that we weren't getting out of kind of their choreography even if something wasn't there. But they were always there if we needed them. Usually we would just tag up at the end of the day, end of a cargo day, and just make sure to tell them exactly what we did so they were up to speed on everything.
Well, I don't know if you got any Klondike bars. Was there any missions that gave you some nice treats?
I think almost every vehicle had care packages from our families on board. And those are always a surprise, so that was kind of cool. We didn't get any ice cream, but we got a lot of fresh fruit. That was kind of cool. That's another thing that I think they hold on to, and if there's any empty space, they'll just cram them in there. But some apples and oranges and things like that were really delicious after not having them for quite a while.
I was gonna say, yeah, definitely a treat compared to it's fresh. It's literally fresh.
And we ate those really quickly.
Well, you kind of have to, right?
Yeah, you don't want them to go bad.
That's very true.
And so I'm wondering, as you get into the coordination that's needed, and even thinking on the side when, we have researchers, scientists who are creating science experiments. It's hard enough just doing it in a lab on your own. And so it's like when people are, and I'm wondering, Dennis, from your perspective of as people design and put these experiments together, but then Dennis on your side, or Shane on your side, actually conducting these things. I'm talk a little bit about that of what goes into making an experiment for someone else to do, and your instructions on how to do it, and it just seems very complicated. I'm looking at you, Dennis.
Okay. So what I'll receive is basically a grant proposal that had a very high science score from a panel of reviewers, right? Mm-hmm. And then I'll start looking at it and saying, can we actually do this in space? Because crew time is very precious. You cannot do things as quickly in space as you can on the ground. We had a 1.4 margin of how long it would take us on Earth at a minimum. It's all got to be done in a self-contained glove box volume. And I start working to make little tweaks and adjustments. Like I said, can we replace this chemical with a non-toxic one? Can we simplify this procedure? What's the tolerance of the timeline? Because if they have to do an EVA, we can't have a time-critical part of our experiment at the same time. They got to be outside the station. So we start looking at every single factor, and it just takes months to organize that. But then eventually we get that down into a set of crew procedures, just like written step by step, every single thing to do, and it should be as simple as possible. Even though these astronauts are like, super well trained and super smart, we make these super simple documents to send them. It's kind of funny. And then the training happens at JWST, where like an experienced scientist will go and work with the astronauts and make a fighter pilot into a biologist, right?
Nice.
And then we send everything up, and then on my end, we're sitting in a control room watching a live video of the astronauts. It's very cool, and talking to them. And we usually, there's one designated person with the best speaking voice talking, and then there's 5 people in the room behind them with total chaos yelling, it's storage locker 5B 6 alpha, and then they go, oh, storage locker 56B alpha, and then we just are in their ear pretty much, walking them through what we need for them to do. I know there's simpler payloads where I think Shane would say you just follow written instruction, but for some of the more complicated things, we're actually talking to them, walking them through.
Yeah, it's very helpful to have Dennis and his team there talking it to us. These scientists in general have spent many, many years creating whatever the experiment it is. The last thing we want to do is mess it up or mess up some of their data or anything. So we want to be very careful. And all that whole process Dennis explained about, getting the experiment approved and then what he's got to do to get it into a crew procedure. That takes a lot of people, a lot of time. And so by the time it gets to us, it's pretty well refined. It's not perfect because like I haven't seen that procedure and I might read something differently than Dennis would read it and so on. So it is so nice to have them on the horn, so to speak, right there talking to us in case we have any questions, so we don't mess up any of the experiment or any of the data.
That's true. And then on top of, off of Dennis's point of making them as simple as possible, a lot of it has to do with the fact that, it's not, you're right, these scientists spend so much time getting these procedures ready for this experiment, but that's not the only one you're doing, right? You are doing quite a few experiments.
Very true. And we're not, in general, we're not trained on all of these. We're just kind of trained generically on experiments. So like Dennis alluded to, making a pilot, a biologist for the day. I was lucky enough to have Peggy there, who is a biologist. So, really, she could help me just kind of understand something that normally I wouldn't understand because it's not in my background. But Dennis and his team can get some really complicated experiment into a procedure that's simple, like you said, so that even I can understand it. That's pretty good.
So what else do you have to train for besides the scientific experiments? Because Dennis also talked about, you have to train for EVAs, and on this last mission you did 4. So that's quite a big chunk of time that takes away from science. And then you got to train for unloading cargo vehicles. What else are you training for?
Yeah, so those are the big ones. Of course, these cargo vehicles, when they come up, we actually use a robotic arm to grab them, capture them. So a lot of our training is with the robotics team to make sure that we do that operation successfully. Grabbing something that's going 17,500 miles an hour is not trivial. But with our training, we always train, of course, for the worst case scenarios, and the vehicles, at least when I was there, behaved very well. So it seemed like it was simple, even though the stress is pretty high, the gains are up because it's a real vehicle and you want to make sure we grab this thing and get it on board. So that's another piece of our training that we do. What else? Those are the big ticket items, like operationally, EVAs, like you talked about, robotics when we're capturing these vehicles, and then most of the other time we're doing experiments. So that makes up most of our days on board the space station.
Yeah. Was it different to use the robotic arm to capture the different vehicles, or did it translate pretty well?
There are differences certainly with every vehicle. So we had, Cygnus, we had SpaceX, we had HTV from Japan. We had a Russian vehicle, but that one kind of docks automatically, so we didn't have to reach out with a robotic arm to grab that one. But there are several differences, and the cues you use are different for every vehicle. So again, we get spun up by our training team a week or two prior to each vehicle showing up, so that we remember, hey, you're looking here, not here, based on whatever the vehicle was, and using certain cues to help get the vehicle on board.
Nice.
I'd imagine that no matter how much you train on that, and I'm sure there's like simulations and different things of like remoting the giant robotic arm. Imagine once you're actually doing that for the first time, it's got to be nerve-wracking, because you're like, this is a very expensive toy. I don't want to mess this up.
Yeah, it was on the first time, and again, we got several opportunities, so it, I won't say it became less important, but you got more comfortable with it. But it is a big deal, and I really wanted Thomas, the French astronaut I was flying with, to get a lot of experience. So when we were together, I grabbed the first one, and then after that, I let him grab all the other ones just to get his experience level up, and he'll go fly again here in a few years, hopefully, and be able to use all that experience to help his crewmates out when he's on board.
Definitely. When you're training to capture these things, like Matt was saying, when you're in the real thing, it's a little bit different. But the training, I've seen it before, right? It's pretty detailed, right? There's like a projection of, it's like I don't know how to describe the training.
Yeah, so we have this, we call it a dome facility, because
Cool.
that's what it is, and the graphics are just fantastic. And it gives you the sense of speed, and as things are coming together, and the rates that you're coming are very, very good. But it's just not the real thing. It's just kind of like our pool. Our pool is amazing to train for spacewalks, but it's just not the real thing. So there are differences, and until you get up there, and now we're in the cupola. We're flying almost all these out of the cupola, which if you think about it, you're upside down flying it, so spatially you got to get your head around, where the arm's moving, even though you're upside down, and those kind of things. So it's not super simple until you actually get up there and do it a few times, and then it becomes a little bit easier on the mind.
Yeah, I can see why they would put you through the training for it, right? Because there's a lot to think about, like just being upside down, using the controls, controlling something from a cupola, but then the arm's over here, I guess. So
Right, so it's not necessarily right out your window. It is in this case when you're in the cupola, but you could fly from the lab as well, and you wouldn't have any windows, and you'd just be using cameras, and that's what we used to do.
Yeah.
That's what we did on my first flight, so things have gotten a lot better in that regard.
All right. I'm sure they write these procedures to be as easy as possible. So Dennis, like, what are some of the techniques you do to, whenever you're writing these scientific procedures for the astronauts, to make it as easy as possible for them?
We try to just boil it down to step by step, but also add in some rationale for why you're doing it a certain way, so that if they don't necessarily have to memorize the exact step, but they can know what the end goal is and why they're doing it. So then they know, like, oh, I should make sure I keep this cold, or I should make sure that I handle this gently, and then hopefully that helps. But I find that most of the time it boils down to, we have the procedure, but then they say, oh, just tell me what to do next, and we're just talking to them. So.
Right. Yeah. Especially when we're in the glove box, right? So
and how do you
we're
read
immobile when we're in there. We can't kind of move around and do things.
And for me, like, going back, one thing that occurred to me is, like, as you're dealing with some, like, if it's a sensitive science experiment or the precious pizza cargo, I kind of wonder, like, when you're packing, I mean, obviously there's a little bit of Tetris where you're trying to place things into the cargo to get it to be very efficient, but it's also, launches are quite intense. And so I'd imagine, Dennis, is like, you'd have to, I'd imagine things have to be durable enough to survive such a crazy extreme, and like launching, and then it's floating out in space, and then the big robotic arm that Shane's operating is grabbing it. But then also on the flip side, Shane, I'd imagine for your, being a human, experiencing that sensation as well. But what goes into, like, keeping things safe and packed in?
For especially things like the rodent habitat, we strap it to a table and we vibrate the heck out of it.
Oh, wow.
It goes through, like, launch impact testing. It gets put through temperatures. It goes through pressurization, depressurization, anything like that. Like, really goes through rigorous testing to make sure it stands up to things. And then it's usually packed in some foam into a locker. Then it's put on a scale so that you can find the center of gravity of that hardware, and also like the weight and dimensions. And then from that, some eggheads do some math, and like some robots like load it into the capsule the right way so it's all balanced. And I don't understand all that part, but we just make sure that we've tested everything to withstand whatever. And I mean, it's pretty excessive. I mean, whatever could possibly go wrong, we like test, worst case, and then we treat it as gently as possible, and then wrap it up and ship it up.
And how is that, Shane, on your perspective of being the human inside said rocket, vibrating and going through those intense pressures?
Yeah, when on the Soyuz, which is what I just flew on, I was very surprised on the launch how smooth it was. So I had an experience on the space shuttle before, and it was kind of rocking and rolling and shaking around like you would imagine. And you see in the movies, but the Soyuz was super smooth. So we pulled about 3 Gs going uphill, but the ride itself was very smooth. So I was very impressed.
So not only like designing the experiments and getting them up, but then you'd mentioned before, Dennis, that it could take years in this process. Yeah. I'd imagine that there's several experiments and ideas that never get into Shane's hands, or great ideas that just either it's like funding or different things. It's a competitive process, and everybody wants their cool science experiment to go up.
We have a queue of investigators going up till 2022. We're trying to get them flown off as fast as possible, but we're limited by launch vehicles and crew time. And crew time is becoming less of a concern because we're getting an extra crew member up there. But now it's launch vehicles and can only launch so many experiments at a time. But there's a whole list of reserve experiments of people that have put their heart and soul into something, and they just need like 15 minutes of crew time, and they're just hoping that their experiment can get done. But I mean, Shane would know. I think they have over 100 experiments at a time on the ISS.
Yeah, I think we ended up doing 273, I was told, over the 6 months. But at any one time, there can be over 100 on board. That's about right.
Yeah, and I remember someone saying, Peggy's going to get every one of those done.
Yeah.
She's going to work through the backlog.
Single-handedly.
Yeah.
We took out all the task list and all the things that were backlogged for sure while we were up there, so it was nice.
Yeah, no, a lot of people over here appreciate it when you guys, give up some of your free time and bang one of those experiments out.
Glad to do it.
That's true. What else, besides if you were to take the weekend to sort of unpack a cargo vehicle, what else are you doing on the weekends?
Weekends, so generally on Saturday mornings, it's spent cleaning. So it's like your house, right? Usually about once a week, you need to probably do a little cleaning. So we spend all Saturday morning vacuuming the whole station, wiping things down, and just getting everything back in shape after usually a busy week. Yeah. And then Saturday afternoons are generally off, and Sundays are generally off. So I'm a big sports fan, so I was usually watching games, whether it was football or World Series or anything going on. Toma got us into watching rugby, so that was big in Europe at the time. So we got to watch some of those matches, and so we do that, as a crew sometimes, or sometimes just individually. You'd watch those things, and you certainly can catch up on emails or watch movies or call home or any of those kind of things as well. Or you can just look out the window, which is always spectacular.
Oh, yeah.
Something you can't do here on Earth. So I try to do that more often because I can always talk to people or email people when I'm on Earth, but I can't always look out the cupola window for, a rev around the Earth in 90 minutes. So that was pretty cool.
That's true.
Curious, how is that set up? Is it like you don't have a normal weekend like you would, it's not like you're commuting home and spending the weekend with your family. I mean, you're sitting there floating in space, so there's never really a day off. You're like always on.
Yeah, correct. And so I had to, when I was the commander, I made it clear to my crew that we were going to work from DPC to DPC, which is the kind of the morning conference with Mission Control, all the way to the evening conference with Mission Control, but we weren't going to work outside of that. There were a few exceptions on the weekends where we would say, hey, let's, there's this one cargo vehicle, for example, we want to unload. Let's do 2 hours, and that's it. We're going to work 2 hours together. If we've got 3 people, that's, equates to about 6 hours of work, and we can do a lot in 2 hours. So, but I would make sure we weren't working all weekend because, as the commander, I got to make sure the crew is not exhausted, for one, so they can hit the next week's activities, when Monday starts. But also, we got to always be ready for that really, really bad day. an emergency on board the space station, whether that's in the middle of the night or during the day, the crew's got to be fresh enough to handle that. So I'm always thinking about that as I'm working the crew, and the crew's being worked by the ground. And sometimes we have to modify what they want us to do in order to keep our reserve, so to speak, to be able to handle an emergency.
That's right. So as a commander, how much jurisdiction do you have on time? Because I know they schedule a lot of things for you, but then what kind of power, I guess, do you have as a commander?
Big picture, I'll talk with the lead flight director usually before the week or maybe even 2 weeks out we'll talk about the big picture, how things are going to flow and what they want to get done. And then the details just kind of flush out. I don't really, have too much influence on that. I'll let the flight director know, hey, here's what I want to focus on. Make sure, we get maybe a day off here or there because we worked last weekend, and those kind of things, because that happens a lot. And then in general, if something's coming up real time, day of, and things, maybe an experiment or something's running twice as long as it was expected, that happens. And then we'll just adjust, real time, and maybe I'll take the activity that Peggy was supposed to do next if she's buried in this experiment, or vice versa. We'll just help each other out to kind of get all the things done. And you do that almost daily. You get done with something early, you go help somebody else if you can, or else you just take something else off of their timeline by knocking out something down the road for them.
It sounds like you guys were really tight-knit. You guys needed to be a really tight team to get all this stuff done.
Totally agree. And I was just super fortunate to have Peggy and Thomas on board for really about 90% of my time on board.
Yeah.
I was with Kate and Takuya for only a week or so, unfortunately for me, because they were superstars as well, but they left shortly after we got there. But so really my whole mission was with Peggy and Thomas on the U.S. side. And we did really work well together. We thought the same. Our work ethic was the same. And we just loved helping each other out and loved being around each other, which doesn't always happen. So I was very, very fortunate.
Hey, that makes me kind of getting back on track to the cargo stuff, though. I was actually thinking about, we were talking a lot about when cargo comes up, how to get it, how to unpack it. But then there's a packing story, right? And they're different for each vehicle, because some of them just kind of burn up. Some of them have experiments running before they burn up. And then some of them actually come back. So what are some of the differences there?
Yeah, so we had all those. So the only one that comes back to Earth is, you're probably aware, is SpaceX.
Yeah.
So, anything that's real critical, experiment-wise, or even maybe broken equipment that engineers want to get their hands on to figure out what happened to it, those kind of things we'll put into SpaceX so that they can come back to the ground. A lot of that has to do with experiments that we did on our own bodies. Kind of blood draws and those kind of things need to come back, as well as rodent research things will come back on SpaceX, because the scientists need to recover them and look at the data and get all that stuff. So that's one thing. All the other vehicles in general burn up, like you mentioned. So to me, I kind of think of it, that's how we manage our trash. All right, that's how we manage trash on the space stations. We create tons of trash, believe it or not, up there, whether it's food trash or clothes trash or experiment trash or waste, human waste. So all that stuff needs to get off at some point. And the way we do that is to use these cargo vehicles that are not coming back to Earth. And we can't just cram things in there like you might think. It's a very organized way of, and again, we'll kind of get a plan from the ground team and Mission Control that lays out how they want us to pack it. And a lot of times there are experiments on board that will happen once it leaves the space station before it gets burned up, like you mentioned. So we got to make sure certain aisleways are clear and the airflow is going to be correct so that those experiments can happen correctly.
Ah, I see. So it's kind of like a supply chain, really, because there needs to be new stuff that's sent up to the International Space Station, and then you need to take some of the old stuff out. So it's that's the cycle that keeps the ISS going.
Correct. Yeah, and launch delays and things don't happen. And these launches aren't always happening on time. So sometimes your trash backlog gets pretty high on the space station. So that's not there are some odors and things that go along with that. So we always like to have vehicles come in frequently so we can manage our trash, of course, along with doing great experiments as well.
But you guys have plenty of food and all that kind of stuff, right? So even if something gets delayed, you'll be set for a while, for at least a lot of things.
I think they have about a 6-month reserve on board. Yeah. So we can handle a lot of delays, I guess.
So Dennis, on your end, when it comes to these experiments coming back to Earth, and especially on SpaceX, the ones that you actually can get your hands on and don't burn up, what are some of the things that you're looking at for those?
looking at getting it back as quickly as possible is usually our priority, especially with rodent experiments, cell science experiments. You're trying to study the effects of microgravity on these organisms. And, the minute you start getting back into the Earth's atmosphere, you're going to start experiencing gravity and see molecular changes. So the clock is ticking to try to get the samples back. So in the future, hopefully, return vehicles can land on solid ground and we get the samples back even faster. Right now, it's taking about a day or two, on a boat in the ocean. But yeah, the priorities, obviously, for animal experiments, we want all of them alive and happy, and so far we've done it twice, and they have been. JAXA has also done it twice. All the mice did really well in return, and intact samples kept at the right stowage temperatures and everything. Then we're happy.
Well, on a similar note, and this is a slight pivot, but I love the little catchphrase of working off the Earth for the Earth. We've talked a lot about how it all happens, from an idea, an experiment, it's created, it's packed, it's sent up, then you actually conduct it. But I'd love to pick your brain, Dennis, and also Shane, of the why. It's why is doing experiments in microgravity important, and why? Clearly, NASA and the international community is spending a lot of money to put this thing up here, and what can we get out of that you just can't do on the ground?
There's a lot that we can't do on the ground. Yeah. My bias is that we want to go to Mars and we want to explore space and we want to make Star Trek real. So we should be figuring out what happens to our bodies, what happens to physical processes on a cellular level, really understand the biology of what changes when the vector of gravity is removed. Of course, there is objectives to benefit the Earth, as you say, and one prime example is you can't have forced bed rest of research animals, but if they're in space, all the gravity load is off, and it will mimic conditions where people have extended bed rest or unloading on their muscles. You also, microgravity seems to have kind of an accelerated aging effect, so you can look at age-related factors. You have fluid shifts and high blood pressure in your brain, and that starts affecting the astronaut's vision and things like that, and we want to understand how that works. So you have a lot of, growing 3D tissues in the lab. To be able to do those kind of things, you may be able to do them better in space and understand the processes better in space. And I think it directly translates into benefits to Earth. Sometimes you have to connect the dots a little bit to see how that space research really affects the ground. But if you look at every experiment we've done, it always has spin-off benefits.
Tough to add much to that, and that's very true. The way I look at it is everything we do up there is either for future exploration, like Dennis mentioned, or it's to help humanity in general. So if we're not doing that, I think we're really missing the boat. But everything that we touched up there and I've been involved with has met one of those two criteria. One example I like to think of is, we have this machine up there that makes water, right? So it takes every bit of liquid on board the space station, from urine to sweat to condensation to anything, and it goes in this machine and it makes water that's extremely pure that we use for our food and our drinks, the next day, so to speak. It's a great technology for us to have. It's not something we have to have for the space station, but we will have to have something like that for Mars or Moon or where we're going to go deep space. So, we're working on that now for future exploration. A side benefit of this whole thing is we actually use that technology on Earth as well. There's third world countries that don't have clean water supplies, and the same technology is helping them get clean water. So that's really a cool thing when you're kind of helping future exploration and you're helping humanity.
That's just one example, right? That's
Exactly.
one thing on the station that's helping in both directions. Nat, I think that's a really good place to end the podcast.
I think that's perfect, dude.
I think that's fantastic because it's kind of sums up, why do we do all the science and why the science goes up and down to the International Space Station. Guys, thanks so much for coming on the show, both to Shane and Dennis for coming on Houston We Have a Podcast and NASA in Silicon Valley. The first time we're doing this together. Matt, I really hope we can do this again.
With our powers combined. It works out. Thanks a lot for helping pull this together. This has been a lot of fun.
Yeah, absolutely. Thanks,
it was
guys.
great. Thanks, everybody.
Yeah, huge thanks to Dennis and Shane. That's awesome.
Houston, go ahead. Stop of the space shuttle.
Roger, 0G, and I feel
The shuttle has cleared the tower.
Became a feast for all mankind.
It's actually a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Never Houston, welcome to space.
Hey, thanks for sticking around. So today we teamed up with the NASA in Silicon Valley podcast to talk about cargo missions. And we had a couple different perspectives with Shane Kimbrough as an astronaut and then also Dennis Levison-Gower as the senior project scientist at NASA's Ames Research Center in California. So if you want to check out all NASA's podcasts, just go to nasa.gov/podcast. That is where you can sign up for the NASA in Silicon Valley podcast and subscribe to them. And there's also a new one that just got released last week, I think, at this point. It's called Gravity Assist, and it's hosted by Dr. Jim Green, NASA's Director of Planetary Science. And he'll start with a 10-part series where he starts with the sun and then goes all the way out to Pluto and just kind of makes his stops along our solar system and then talks about planets beyond. This is going to be a really cool podcast, so definitely stay tuned. We were talking about cargo missions, so definitely tune in to the live coverage of the launch and capture of SpaceX CRS-13. I think SpaceX covers the launch, but you can find the latest times for the capture of CRS-13 on nasa.gov/NTV, as in like NASA TV, and you can see the latest schedule for when we're going to be broadcasting that. Make sure to follow us on social media, Facebook, Twitter, Instagram. Use the hashtag AskNASA on any one of those platforms to submit an idea for the podcast, and make sure to mention is for Houston We Have a Podcast if you want it answered here. So this podcast was recorded on November 14th, 2017. Thanks to Alex Perryman, John Stoll, Greg Wiseman, Kelly Humphreys, Megan Sumner, and Brandy Dean from here in Houston. And thanks to Matt Buffington, Eric Land, Abby Tabor, and Frank Tavares from NASA's Ames Research Center and teaming up for this podcast. Thanks again to Shane Kimbrough and Dennis Levison-Gower for coming on the show. We'll be back next week.